All right, I am so sad that I'm not going to be here for my favorite day of the year. We are going to do the packet of joy. Together, we're going to do the first problem, and I'm going to walk you through this process so that you can be successful on completing the other 3 problems in this packet tonight for homework. So, pay attention, take notes, write down everything I write down, and hopefully it's going to go great. Can't wait. Here we go. So, the first thing we're going to do is we're going to read the story problem and we're going to underline important information. So it says, a bookstore manager is purchasing new bookcases. The store needs 320 feet of shelf space. Let's underline that. The bookcase A provides 32 feet of shelf space. I think I'm going to underline that in blue as well, because that's talking about shelf space, and so was this. I'm going to change to a different color, and I'm going to underline that bookcase A costs $200. That's a money, so I'm going to underline that in a different color. Then it says bookcase B provides 16 feet of shelf space. That's back to blue, because we're talking about shelf space. But bookcase B costs $125, so that's our red stuff. It says because of space restrictions, the store has room for at most 8 of bookcase A. So at most 8 of bookcase A. And at most, is still in play, at most 12 of bookcase B. Notice I switched to green to talk about this bookcase A and black pen to talk about bookcase B. Lastly, I'm going to highlight this last sentence. It says, how many of each type of bookcase should the manager purchase to minimize cost? That is the goal of the problem. How many of each type of bookcase should the manager purchase to minimize cost? Okay, deep breath, here we go. Let's decide what we're going to call X, and let's decide what we're going to call Y. What are the 2 unknown things that we are finding in this problem? Well, we're trying to figure out how many of each bookcase. Well, we have 2 types, bookcase A and bookcase B. So bookcase A was the first thing listed in the problem, so that is what I'm going to call X. Bookcase B was the second one, so let's call that B, or Y. Okay. The last couple days we've talked about our constraints a little bit and how to set up the equations. Now I've been talking about 2 equations that I call the freebies. So I'm going to put a star by these 2 spots. These are going to be the freebies in the problem. Because remember, are we going to be making or having any kind of negative amounts of bookcases? No, we're going to be in the first quadrant. We're going to be up here talking about the positive number of bookcases that we can put into this store. So we are going to put 2 equations on here that I call the freebies. Your X has to be greater than or equal to 0, and your Y has to be greater than or equal to 0. Okay? Now, we're going to make a little chart for ourselves to organize the rest of this information. I'm going to make that chart up here, and I'd like you to make this chart with me. And I highly, highly recommend that you do this when you're doing these problems. So we have X and we have Y. And we have things in this problem that they told us about. They told us about shelf space. So I'd like you to label one of the spots in this little chart as shelf space. Then they talked to us about money. Okay, they talked to us about money. So the cost, that's another column of information in this problem. And then the other thing they talked about is they talked about the space restrictions. The space restrictions, like we could only have 8 of bookcase A and 12 of bookcase B. So the other one I'm going to call our space restrictions. Okay? So let's take our information and put this into the chart. So we had the store needs 320 feet of shelf space. Is that a total, or is that talking about bookcase A or bookcase B? That is a total. So I'm going to put that down here as a total for the shelf space. We cannot go above 320. Actually, we want more than that. It needs that much. Sorry, I said that wrong. It needs 320. So we'll talk about that in a minute, of what symbol that means. Then it says, specifically, bookcase A provides 32 feet of shelf space. So I'm going to put that down right here under X, because X is bookcase A. So 32 is shelf space for bookcase A, which is X. Then let's go to the other thing I underlined in blue. 16 feet of shelf space for bookcase B. So that's going right here. So this right here is one of your equations. I've set it up so that it's an equation, it's a vertical equation. So I'm going to write, this looks like the long line of our equations. I'm going to write that one right here. So that equation is saying 32 of X plus 16 of Y. It says we need, I need 320 feet of shelf space. So that's going to be greater than or equal to 320. So that's one of our constraints in this problem. All right, the next one we're going to talk about is cost. Cost is 200 and cost is 125. So it costs us 200 to order bookcase A, and it costs us 125 of bookcase B. Now, what was the last sentence I highlighted on this? It says, how many of each bookcase should the manager purchase to minimize our cost? So minimizing cost is the goal of this problem. So that's actually going to be down here as the objective. So the last sentence in these is usually your objective. So this stuff about cost is going to go down here as your objective. So I'm going to say C equals, our cost equals 200 of X plus 125 of Y. Those are the bookcase costs. And the goal is to minimize. So when I have this here, comma, blank, we're saying to minimize our cost. So you're just really filling in the information that we're going to be doing in this problem. All right, so far I've got freebies, I've got the shelf space, and I have the cost, and that's the goal of the question. The last thing we talked about up in the problem was the space provided. Like the store only has so much room for these bookcases. It says at most 8 of bookcase A. At most. So is that bigger than or less than? At most. So it's saying less than or equal to 8 for bookcase A. So this right here is an equation. X has to be less than or equal to 8. And the other one, it still says at most 12 of bookcase B. So less than or equal to 12 of bookcase B. So Y has to be less than or equal to 12. All right, so setting up the equations is the hardest part. And if you can get this all set up, the math part of it is going to be the easier part of this. So once you have all these constraints and your objectives set up, hopefully things are going to go well for you. So let's head down to the graph. It says, graph the constraints and shade the feasible region. So I'm going to go ahead and start graphing. Let's do our freebies first. So we know that we're in the first quadrant. We're greater than 0. We're greater than 0. And that just puts us in the first quadrant as it is. Now I've marked down here on your graph for you what I want you to go by. So it looks like on these we're going by ones. So this is 1, 2, 3, 4, 5, 6, etc. So if you want to take a minute to label those And let's do this other side by the same. I'm gonna mark the spots that are 5. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. I'm just gonna kind of get this all labeled up here. So I've marked some things that we might need. Okay, so I've done the 2 freebies. Let's go do the green equations. We want x to be less than or equal to 8. X. So x is right here, ladies and gentlemen. So we're going to draw a vertical line at 8. And we want to be less than that. We only have so much space for these in our bookstore. And then the other one is y is less than or equal to 12. So I'm going to go to y is 12, draw my line, and then show less than that line. So right now it's narrowing us down to this rectangle spot down here. So the next thing we need to do is we need to figure out how to graph this last equation right here, which is 32x plus 16y is greater than or equal to 320. Let's write that over here because we have some work to do on that. So rewrite it over here, please. 32x plus 16y is greater than or equal to 320. Okay? What I've been having you guys do is solve this with intercepts. So we are going to do that here. So our x-intercept, that's where we're going to plug 0 into the y position, and we cover up, and we divide by 32, and we get 10. 10, 0, 0. Similarly, our y-intercept, we're going to put 0 here, and then we're going to find this one, divide off 16. 32 divided by 16 is 20, or 2, so that would be 20. Okay, so let's plot these on our graphs. We're at 10, 0, and 0, 20. Oh, I got to go up here. So there's 20. Okay. Now you probably will need something to help you with making a straight edge, so that you can make this really nice and straight. I'm going to go like this. And then notice that I was greater than this line. I need to make sure that I have more than enough shelf space in my place. So that's shaded this way. So that is putting us into this being our feasible region. This little triangle in here is our feasible region. So now we need to mark the spots around the edges of our feasible region. Let's circle all those spots. We've got these two where they cross in the green, this one here, and this one here. But mathematicians, this part's really important. I am not for sure that this crosses through at that exact location. I am not for sure that this crosses through at that exact location. So we have to use, when we've been doing this chapter, we have to use substitution or elimination to find those positions. So that way we know for sure that that spot is at the grid point that we think it's at. I hate to say it, but it's kind of like geometry proofs. You have to find that spot to know that it's exactly where it is. So you have to prove it to me. So over here, I'm going to show proof that that spot is what it looks to be, which is like 412. So let's go and prove that. So this line right here is y is 12. And I'm just going to change these to equal signs right now. So y equals 12 is crossing at this equation. This blue line with this green line. So what I need to do is I need to take this, and in this case I'm going to use substitution. I'm going to substitute it in there. And I'm just going to use my calculator right now and do 16 times 12 and get 192 equals 320. Subtract 192, so 32 equals 128. Divide by 32, Yep, x equals 4 right there. So I know that y is 12 and x is 4. That's one of the spots that it crosses at. So let's go down here and mark that. So we're at 4, 12 is one of the key vertices. I do know that this one right here, these two green lines meet up at 8 and 12 because they're straight vertical and horizontal lines. I already know they're at 8 and 12. Now I need to find this one's mystery point right here and make sure it lists it where it's supposed to be. So now, which two are crossing? Well, this line right here is x equals 8, and it's crossing with this line, 32x plus 16y equals 320. So I need to take this and substitute it into that location and prove that spot. So 32 times 8 plus 16y equals 320. So 32 times 8 is 256, so I'm going to subtract 256 from both sides. So 320 minus 256 puts me at 64. Divide, divide, y equals 4. So that spot is at 8, 4. And I've proved it through elimination and substitution are the two choices of ways to find those spots. All right, we are almost there. You're doing so great. Keep it up. So the next thing we're going to do is we're going to take these values, and it says evaluate it into the objective function. Ooh, what was that again? The objective function right here. What was our objective? It was to minimize our cost. So we're going to take these numbers and we're going to see which one of these minimizes our cost. So cost equals 200 times 4 plus 125 times 12. And we're going to do that for all of them. I'm just going to fill these in right now. Okay, and then you can just type, use your calculator to figure out what the cost would be for these different parameters, these different vertices spots around the corners. So we get, 2,300, 3,100, and 2,100. So which one is minimizing things? The one that's the smallest amount of cost would be this one. So now the final thing you do is you write a sentence. So I would say, the manager should purchase 8 of bookcase A, 4 of bookcase B, and then you can't stop there. You have to say, to minimize. Tell them what the objective was. To minimize the cost at $2,100. All right, good luck. You're gonna do great. I'll help you tomorrow. Keep it up and keep smiling. Thank you.